Hi, everyone, and welcome back to Iowa Ideas In-Depth Week. This week's focus is on drinking water, and the name of today's session is Emerging Contaminants. For those who don't know me, my name is Brittany Miller, and I am the Energy and Environment Reporter at the Gazette and the co-lead of the Iowa Ideas Energy and Environment track. Before we get started, I'd like to thank our Iowa Ideas presenting sponsor, ITC Midwest, and our In-Depth Week sponsor, LaRue Law Office, for their support. We're going to watch a quick video from the LaRue Law Office first before we get started. Let's see, we've been having some technical, there we go.
Hello, I'm Jim LaRue of LaRue Law Office. I'm pleased to be your In-Depth Week sponsor for this week's critical conversations on drinking water in Iowa. Iowa's abundant freshwater supplies, once upon a time, were among our state's most important and precious natural resources. Now, that prized Iowa resource is at grave risk. Iowans are faced with a huge and unprecedented water pollution challenge. Fortunately, when facing large challenges, over the years, Iowans have often worked together to make things better. By improving our freshwater resources in the future, Iowans will reclaim an important part of our natural heritage. It's the Iowa way of doing things. Let's get going.
Thank you for that. And now I want to introduce the expert panelists here for today's discussion. Actually, I'm going to have them introduce themselves. So let's go in the order of my screen. Let's do Greg, Christy, and then David.
All right. I'm Greg Lefevre. I'm an associate professor of environmental engineering and science in the Department of Civil and Environmental Engineering at University of Iowa and IHR Hydroscience and Engineering. And I've been here since 2016, and I study emerging contaminants.
Hey everyone, my name is Christy Romakal. I'm an associate professor at the University of Wisconsin, also in civil and environmental engineering and chemistry. My group also focuses on emerging contaminants. We work on what impacts these chemicals in natural systems like lakes and rivers, and also in engineered treatment applications.
Hello, I'm David Andrews. I'm a senior scientist at Environmental Working Group based out of Washington, D.C., where I've been for 14 years after finishing my PhD in chemistry, and have focused on chemical regulation broadly, but more specifically on chemicals in drinking water and chemicals in consumer products. So exposures that people have to, or everyday exposures that Americans have to chemicals. And a pleasure to be here today. Thank you.
Thank you all for being here. We're really excited to have you. So yeah, as you all know, or hopefully know, we're going to be chatting about emerging contaminants in Iowa and the Midwest at large today. And this discussion will identify some emerging contaminants, how they impact communities and their drinking water, how they are or are not regulated, and how they can be treated. I'll be reserving the end of the call for any audience questions, so please feel free to pop those in the chat throughout the session. So let's get started with our discussion. I think it would be great for us to just start off with defining what exactly are emerging contaminants and, giving some examples of what we see, in Iowa and beyond.
So one of the things that our little group did before the live conversation here was to kind of talk about what an emerging contaminant actually is. And it's actually somewhat a little bit amorphous to define, and when has something emerged or what is it and stuff. And so I looked up the kind of the formal working definition that the US EPA Office of Water uses, and they apparently actually prefer the term contaminant of emerging concern, or sometimes they refer to it as a CEC. And they define it as a chemical or other substance that doesn't have a regulatory standard, and it's oftentimes recently discovered in aquatic systems, and it has the potential to have deleterious effects on either ecosystems or people. And they're not necessarily included in routine monitoring, and we don't necessarily know the full effects of it. So some examples of these are not necessarily compounds that are new that we don't know that exist, but they're being newly discovered in terms of where they are. So some of them are actually persistent organic pollutants that are being found in new places. So examples might be flame retardants, or PFAS, which we'll be talking about, I'm sure, later on. Pharmaceuticals, personal care products, either prescription or non-prescription drugs. Veterinary medicines like antimicrobials, antibiotics, as well as endocrine disrupting compounds, which would be things that would either natural or synthetic compounds that would disrupt or change the hormone systems of animals, either on purpose or on accident, and other things like nanomaterials these are listed. Other things that we also study in my lab are new market pesticides, because oftentimes these are things that are, they're approved for usage, but we don't necessarily anticipate the full extent of where they might end up in the environment or how they might transform in the environment, because sometimes the products, the things that they transform into are not necessarily benign either.
Thank you, Greg. And you kind of mentioned some of the impacts of these contaminants. Can we kind of delve more into that, like how exactly these contaminants can impact, humans through our drinking water?
Do you want me to start?
That can be for anyone. Yeah, if you want to go for it first, Greg, go for it.
I think one of I'll let other people jump in here, but one of the things that kind of defines, or they don't necessarily have the traditional acute toxicity endpoints that some other toxic compounds do, where you can go in and measure, like give a fish or an insect or something a specific dose and then see a really strong effect. Sometimes the impacts can be much more subtle. For example, hormone disruptors can actually change the way the normal functioning of a organism is, like their growth and development, but it doesn't actually kill them. So the effects can be much more subtle and also present in the form of mixtures too.
I can jump in as well. I mean, I think we're talking about a lot of different kinds of chemicals here. And so my favorite answer is it depends. There's going to be a lot of different effects. And so even for PFAS, for example, there's a big laundry list of potential health effects, cholesterol issues, thyroid issues, decreased immune response, even cancer in some cases. And that's just for one class of chemical. Another one that we think about having important health outcomes are like antibiotics, and those can perpetuate antibiotic resistance, which can be problems. And sort of as Greg alluded to, something we don't really understand right now is, we're often exposed to these chemicals in mixtures. And so what are the mixture effects? Those are things we don't really know, but it really depends on the chemical. There's a lot of different potential impacts.
Yeah, I think those are two great answers. And to add on to this and go back to the original definition that Greg presented on emerging contaminants as contaminants without a regulation, there have been no new regulation set for emerging contaminants since the Safe Drinking Water Act was passed in 1996. So that's 2.5 decades where our scientific understanding of how low dose exposures may impact health, or as just mentioned by Christy, mixtures of chemicals may be impacting health. There's a lot we also do know about some of these chemicals and the potential health impacts, but the regulatory structure hasn't caught up with the science. And so there are a lot of different ways that these contaminants may be impacting health. There are a lot of studies that have been done, both documenting increased exposure to certain chemicals, or at least the extent of exposure, as well as linking that to a wide variety of potential health outcomes. But I agree, it completely depends on the contaminant and the exposure. So a lot of different ways that these chemicals could be impacting us.
One thing that I like to think about to add on to that in terms of the types of chemicals, and there is a very simplistic way, is like sometimes we like with complex mixtures of all these different things and stuff, is that pharmaceuticals are FDA approved and are designed to help people get better, right? Even though there could be not good unintended effects, there's still if you contrast that to pesticides, which are designed to kill things, those are very different goals and outcomes, and can really be drivers of differences too. So sometimes knowing what like their design is too can help me.
You know, we've thrown around the word PFAS a couple times so far, and can someone define that for people who may not know what it is and where they come from?
I'm happy to jump in. So PFAS, PFAS is representative of a large family of anthropogenic or man-made chemicals that contain carbon. So they're organic chemicals that contain carbon and fluorine. And so carbon and fluorine are one of the strongest bonds that you can make. And what makes these chemicals very persistent in the environment. But it's a family of chemicals. I think the two most well-known are PFOA, which was used to make Teflon, and PFOS, which is used to make Scotchgard. And so those are two examples of chemicals in this family that have shown to be very problematic, were phased out of use about over the last 15 or 20 years. The replacements have also shown very similar concerns, and actually in the United States, there have been about, or just over 1,000 PFAS chemicals that have been approved for use by the EPA on an industrial scale. And then there's many more breakdown products or byproducts that have been identified. So it's an enormous family of chemicals that are very persistent in the environment. They really resist breakdown, and it's because of this carbon fluorine bond.
Thank you, David. As Christy said, I was going to ask like how these chemicals get, you know, into our water supplies. And as Christy said, it depends. So can you guys kind of go over some of the different ways that, you know, they get into our water supplies and how it can threaten that?
Sure, I can start. I mean, with PFAS, there are many different ways. You know, one of the big routes of environmental exposure is the use of PFAS containing firefighting foams. So we often find contamination near military sites or airports that have used firefighting foams. But PFAS are also present in industrial wastewater, and so they're part of the wastewater treatment cycle. And so wastewater treatment plants aren't designed to remove PFAS, but they don't make PFAS, but they don't remove it either. So PFAS is often associated with wastewater effluent, which I'm sure Greg is going to talk about here in a second. For other chemicals, as well as biosolids is something we think about. Landfill leachates, there's kind of a laundry list of different sources. For those kind of chemicals, pesticides are another good example. These are, you know, I don't know, there's probably for debate if these are contaminants or not, because we add them to the environment on purpose. They're obviously applied in agriculture. My group does a lot of work studying pesticides that are actually added to lakes and rivers on purpose to control invasive species. But they, of course, have biological effects there as well. Hey, Greg, I don't know if you want to jump in on more wastewater stuff.
Yeah, I mean, we do know that there is a lot of compounds that are in wastewater, and some of the studies that our group has actually worked on has actually shown that for example, that there can be actually quite high loadings of pesticides in wastewater to the stream, and that led us to kind of look at what are the approved usages of these things and other things, because one wouldn't expect that to be in, for example, agricultural drainage where these pesticides are being used and stuff. But some of the ways that people actually can be exposed to emerging contaminant pesticides are through usages actually in the home, and that can create a very direct human exposure route, particularly for vulnerable individuals like little kids that are, you know, putting things in their mouths all the time and crawling around on floors and stuff. And you going in and doing things that are like monthly pest control programs to keep pests from growing in and around building foundations and stuff actually can go in and put a lot into the drains and stuff. And when things like flea and tick controls on pets and stuff can actually be a large source into wastewater as well. So what people, our finding was really interesting insofar as that what people were using in the home, it's all indoor usage because it's all going into the wastewater treatment plant from municipal usage. So it's demonstrating that whatever people are going in there, it's coming from within the home. And one of the things that we were joking is that cats don't shower. So whatever things were placed on a cat were then getting into all over the home, because then the cat is probably sleeping on a blanket, and then the blanket eventually gets into the laundry and then it gets washed off or something. But people are probably also getting exposed to that directly and things too.
Greg, and I think Christy, you both kind of alluded to how these chemicals can mix and interact with each other, out in the wild. Can you kind of elaborate more on that and the dangers with that?
Did you want to take that first, Chrissy? Okay. I guess one of the reasons why we've been really interested in that from an ecological exposure perspective is that, particularly from a pharmaceuticals, even these are again designed to be something that are supposed to help people and stuff, but at low levels they can have important effects. And one thing that I always say is like, what is if you go to a doctor's office, what's the first thing that she's going to ask you if you need to get prescribed a new drug? Are you taking anything else with this? Right? They wanted, like, is there the potential for bad adverse drug interactions? And when organisms are exposed to a whole mixture of things, those outcomes can be actually very difficult to predict. And our traditional forms of ecotoxicology don't, we want to understand how a system works. So you want to, be as scientific as possible, which oftentimes means you do things one at a time to be reductionist and understand it. But though organisms are very complicated, especially when you get into things like fish and stuff that we are really interested in. And so that's why mixtures can be difficult, but really important. And humans get exposed to mixtures all the time through the air that we breathe and the water that we drink.
The only thing to add to that is I think that we have a lot to learn on this topic. It's really hard to study because how do you figure out which chemicals do I mix together in my study? What concentrations, even how to design that is really difficult. There's probably an infinite number of possibilities. And so I think we have a long way to go with the science for being able to understand and to predict. I think we have quite a ways to go.
Mm-hmm. Can we talk about how emerging contaminants are monitored and regulated or not regulated in our drinking water?
I'm happy to jump in here in terms of, at least at the federal level, there's a program called the Unregulated Contaminant Monitoring Rule. So EPA has a mandate that every 5 years, there has to be nationwide testing for a set of 30 contaminants, and it's a changing set of contaminants. And this is all utilities that serve over 10,000 or 3,000 people, depending on the year, have to test for these contaminants at least a few times. So this is one way, at least at the federal level, that information is being collected on some of these emerging contaminants or non-regulated contaminants in drinking water, their occurrence and at what level they're occurring. And that's actually that's the primary mechanism the agency has to collect information on occurrence of emerging contaminants. And there's a requirement for drinking water regulations that you show occurrence in drinking water systems, and that a regulation will have meaningful public health benefit. So that's one of the primary routes of at least collecting information at the federal level, and it leads into regulations. As I mentioned, though, since the Safe Drinking Water Act was passed in '96, no new contaminant has gone through that process to the point of setting a regulation. Although just 2 weeks ago, the Environmental Protection Agency proposed drinking water regulations for 6 PFAS chemicals. So this is somewhat historic in terms of moving through the process of setting a new drinking water regulation for emerging contaminants. It's actually addressing 6 PFAS chemicals, which came as a little bit of a surprise. I think the proposed regulation was just for PFOA and PFOS. the concentrations are very low, in the low parts per trillion range, 4 parts per trillion for PFOA and PFAS, slightly higher for 4 other similar PFAS chemicals, and would have an enormous impact on water systems across the country. The EPA actually did calculations on how many water systems could be impacted, how many would need to install filtration, and it may actually change this whole conversation in terms of emerging contaminants and how many emerging contaminants are in water, because I believe they estimated 3,000 to 4,000 systems would potentially need filtration at the levels they proposed. And the filtration mechanism, or the primary filter used for PFAS contaminants is called granular activated carbon. It's like charcoal, and it's actually, it works relatively well to remove other contaminants in drinking water too.
Christy, Greg, do you have anything to add on that?
No, I think that was great. I mean, sort of like what Greg said at the beginning is these chemicals aren't regulated. So the sort of exactly as David said, the proposed regulation for PFAS is, well, long overdue and is kind of a new thing. And yeah, it's going to have some really big impacts across the whole country.
Yeah, I'll follow up both of those statements. I totally agree with that. Kind of a tangible story that we've worked with here from some of our research and kind of comparing and is that there's a lot of potential benefits associated with improving drinking water quality that will come from the going in and meeting the regulations for PFAS. Particularly, I mean, we'll use the granular activated carbon example, which is basically like a big kind of glorified Brita filter, right? We did a study a few years back where we were looking at neonicotinoid insecticides in drinking water, and we were comparing the University of Iowa system, which was at the time a conventional coagulation population, which is just standard approach, versus the way that the city of Iowa City has a different water treatment system that does use activated carbon beds. And the real reason why they did it was because the water tasted bad. And so that's reason number one. And so that dramatically increases because then it makes the taste better. It gets rid of a lot of the organic matter that makes the water kind of smelly and taste fishy and stuff. But the other reason is that if there is that kind of organic matter in there, it can go in and it can cause later what are called disinfection byproducts, which are regulated. And oftentimes they're carcinogenic and other things, and they don't want those in there. So they want to remove those. And so they put in these GAC beds when they made the new plant. And when we studied the contrast between those two plants, the neonics were very effectively removed from the city plant that used the GAC beds. And in addition, when we did a coring of the used GAC filters, we found over 50 different, I believe it was 57, or it was a lot of different residual pesticides that were stuck on there that were not moved into the water. And so that's kind of a type of thing where when they're trying to go and improve the water quality so they don't have a violation of their disinfection byproducts, which is a regulated pollutant. But one of the outcomes of it is that they're actually improving the water quality for all kinds of other emerging contaminants. They're not actually regulated.
One quick add-on to that's worth noting that buried down there in the EPA proposed rule, they actually have to do a cost-benefit calculation. And so they do have the estimated cost for doing for adding all of these filters to systems. But on the benefit side, they didn't calculate the benefits just from reducing PFAS in these drinking water systems. They also included health benefits for reducing or removing disinfection byproduct levels. To this point of how these filters are likely broadly applicable to reducing many emerging contaminants, as well as some of the regulated contaminants that have been associated with health harms.
You all have mentioned different treatment technologies. Can you quantify like the cost of those? And is that something that, can be come by smaller rural water suppliers like that we have here in Iowa?
Yeah, I don't know. I'm looking to David to see if you had thoughts on cost. I mean, I think your point is a good one about, if the costs in a water utility are spread across a number of people that are drinking that water. So smaller water utilities that serve fewer people, some of these costs are going to be really significant. But I don't know, David, if you have specifics on maintenance or installation of these sort of systems.
I don't have specific costs, and it's a really interesting question. In the infrastructure bill that passed this, just to note, in the infrastructure bill that passed this year in Congress, there was an additional $2 billion earmarked for compliance and removing PFAS and emerging contaminants in smaller water systems, because as the system size gets smaller, the cost, if distributed to each person, would be more expensive. I think this is something that the agency is also collecting more information on with the proposed rule for PFAS. It's absolutely a difficult problem in terms of how to address, and it's one that actually the state of California has been grappling with in terms of regulating the contaminant chromium-6 in water, and this really sticking point of to meet more health protective standards is easily achievable for large water systems, but for very small water systems, it's not economically feasible for them to meet it. And so it's a question of, where do you set the health protective standard? Is it one that only the large systems can meet? And if so, how do you address the drinking water in small systems or in disadvantaged communities? So there's a lot that goes into that question. And for removing for GA or granular activated carbon filters for water systems, it can be quite expensive. And I think we'll learn much more about that in the next coming years too, in terms of if there are thousands of systems that need to install this filtration, get much more information on how much that will cost.
Mm-hmm.
There are definitely differences in what types of different processes cost different things, and the activated carbon beds are relatively less expensive than some other technologies that are used in different places and stuff. If people use different like ion exchange or reverse osmosis things or something, and honestly, like those are like an activated carbon bed is will be much cheaper than some of the like the reverse osmosis that the like Des Moines is using for nitrate control, and that is much more expensive, and is there for doing that kind of thing will be much more burdensome, particularly to smaller communities that have nitrate issues in. I know we're not specifically talking about that today here in the session, but is an important co-contaminant in a lot of rural groundwater in places in Iowa and throughout the Midwest too. And that's a very difficult challenge to deal with, and is not going to be, the GAC bed is not going to work for that.
And quick plug, we're going to be speaking more on that tomorrow when we're chatting with different department heads from different cities around Iowa about how they troubleshoot water challenges. So stay tuned for that, audience. David, you mentioned how the proposed regulations for PFAS are historic. As experts who study these emerging contaminants, do you think that there should be more regulations?
I think we should be doing a much better job nationally and at the state level in terms of understanding the extent of what we don't know about what's in drinking water. I think there could be much more comprehensive testing for unregulated chemicals, and that would lead to potentially more regulations. But in many cases, the solutions may be similar. So it may just be that as we collect more information, there's greater support and for cleaner drinking water.
Yeah, I would agree with that. As scientists, more data is always good, and we need to find out what we don't know. But I think people have been pushing for the PFAS regulations for a very long time, and those are ones that we know have human health outcomes at these very low levels that are being proposed. And so I think it is really good to see movement in that direction at the federal level. Obviously, there's been like a patchwork of states coming up with regulations with very different numbers, many states with none at all. And so, yeah, having that at the federal level is really good to see. And sort of has been alluded to already, you know, some of the treatment systems will work on many other chemicals as well. So I think we're moving in the right direction. It's a slow process.
Greg,
An Iowa connection, I know that at least some of the quotes from the DNR are that they basically look to the EPA for their regulatory guidance. They don't go in and make their own regulatory standards. And so that's why having that federal guidance on that will be really important, so that regardless of what state you live in, you are still having clean water to drink.
I'm glad you brought that up, Greg, because we have the privilege of having some panelists from outside of Iowa. I'm curious how Iowa's take on PFAS regulation differs from other states. I know some have already, have their own MCLs for their state. As Greg said, Iowa has waited on EPA guidance.
Well, I can jump in on Wisconsin. So we're neighbors, I suppose. I mean, there's a lot of politics that goes into this. I think there's no getting around that. I mean, in Wisconsin, there was a proposal of 20 parts per trillion for PFOS and PFOA, and then political reasons, it ended up being set at 70, which was what the EPA, the old EPA health advisory was, and then that all got kind of blown out of the water. But yeah, there's a lot of politics that goes on. Other states have taken, I mean, the numbers vary quite a bit. Some are at 70, some are lower. I think there's a couple that are higher. It really ranges a lot. So yeah, there are many states that don't have anything. I don't know, David, if you want to chime in on more national picture.
Yeah, I think it's been mixed, and in part because that EPA has federally been looking at standards for PFAS. I believe there's 10 states that have established standards, but the proposal at the federal level would be stronger than all of those. So at some point, maybe this is coming to a single value across the country in terms of a standard. And ultimately, drinking water standards are a combination of what we know about the health harms of the chemical and what a safe level of exposure is, balanced with technical feasibility, cost, and there is also a political calculus, both at the federal and state level, in terms of setting drinking water standards. And those standards typically don't match what we know in terms of what the ideal level of exposure is, but that's because we're bringing in these other factors in terms of cost, feasibility. So I think it's worth keeping that in mind.
Yeah, in the proposed rule, the goal is 0. So, and that's important to recognize, is that it's not some levels below 4 parts per trillion are not somehow considered safe. It's just that that's what the limit would be.
Mm-hmm. In our conversation so far, we've talked about some treatment options for, public water supplies, like larger scale treatments. Can we talk about some treatment options for like residents, like on the residential scale? Is there anything that, regular people can do to keep their water safe?
I guess I can start with that. I mean, I guess one thing I'll say is all the treatment things we've been talking about, at least in terms of PFAS, they're really good at removing PFAS from water, but they don't destroy the chemicals. And so like your spent activated carbon go back to the landfill and they kind of are part of the cycle. And so that's something to kind of keep in mind, is that they do the job of making the water safe to drink, but I don't think we're quite there yet with a good destructive solution. So just to sort of make sure that we're all aware of that. But that being said, many of the things we've been talking about can also be done at the home. Like at my house, we have an under the sink water filter, which is basically granular activated carbon. It removes the PFAS that's coming into my house. That can be done. There are also like home RO systems, which again, like Greg mentioned, are going to be more expensive, but there are sort of these, kitchen sink or home sort of treatment systems that can be done if that is needed.
Sure, and I'll just add there are some differences in cost, right? The from the Brita or the carbon filters that attach to your faucet to the ones under the sink, they're typically tens to $100, give or take. And those are relatively effective at removing or reducing a large range of contaminants, from the disinfection byproducts to other emerging contaminants like some of the pharmaceuticals, organic compounds, as well as PFAS. They're not completely effective, especially for some of the shorter chain PFAS. And it's important to change your filter regularly. And actually, interesting study in especially some of the home use filters, depending on what other contaminants are in there, once the filter saturates, you can actually get those PFAS will be removed back into the water if you're not changing the filter. And in some cases, the level was higher in the filtered water than in the incoming water because of that. So not typical, that's something that doesn't typically happen with the reverse osmosis systems, but those usually cost a few $100s installed under the sink. And they actually have a carbon filter before the reverse osmosis filter. So slightly more effective at removing a broad range of contaminants and doing it to a lower concentration, but costs more.
David, I'm really glad you said that. I just wrote myself a note to talk about maintenance. So whenever people are thinking about putting in these kind of filters in their home, it is super important. It's not like you just put it there and forget about it forever. You do have to replace them. I think the one, like I said, at our house is every 6 months. It actually beeps at you after every 6 months, so you don't forget, which is really good. But if you're doing something like this, you do really need to follow the recommendations and actually maintain it and replace it, because like David said, you can run into problems. So I just want to reiterate that, because that is really important. Something you're doing to try to protect yourself could backfire if you don't take care of it.
I'll add to that the home RO systems that people have are probably most people are most familiar with those if they are on a rural well that has high levels of nitrate in them. I mean, you shouldn't need something like that if you're on city water or on a municipal water, right? They have to meet the regulations, right? The water that you drink out of your tap is going to be safe in that capacity. In terms of most things, you can kind of think of those end of tap being kind of a little bit of a polishing step if you are doing that. Those rural wells, I think, are a big challenge because they're very distributed and really difficult to go and work up. And I know that you guys, Brittany, had a special session on specifically wells, right? And some of the challenges that are associated with there and whatnot. And reverse osmosis systems for putting in somebody's basement or something like that can be very expensive, difficult to maintain. They waste a lot of water and can sometimes take out good things like good minerals from your water too, from there. So it's definitely, it's much cheaper and much better to have the treatment be at a water treatment plant than in your basement.
So I'm going to learn my lesson from yesterday when I ran out of time to ask audience questions, and I'm going to jump over to them because they have a lot of good questions for y'all. So first, we have a few comments on asking about the safety of bottled water versus drinking water from the faucet. And are there any standards for bottled water?
So we've done a few reports on bottled water and versus tap water, and we generally recommend that people stick with tap water and consider filtration options at their home as an alternative. In many cases, there aren't formal standards. There will be potentially industry standards. I know there are some for PFAS and some other contaminant levels, but oftentimes it may just be filtered tap water that's in the bottle. And so in most cases, we recommend that you should consider just having a filter and using a reusable bottle from home.
I don't know if there's anything else to add from Greg or Christy.
Just agreement, 100% agree.
Cool. Earlier, Greg, I think you were talking about wastewater treatment. Someone asked, are you saying wastewater treatment plants can concentrate some of these chemicals since they're not regulated?
sorry, I probably wasn't being clear there. So I'm glad for the opportunity to clarify. It's not that they're concentrating them, it's that they are coming in from really kind of distributed sources, like everybody's homes, right? And they're kind of going into the wastewater treatment plant. And, they will remove, wastewater treatment plants will remove a good amount of things, but they're designed to go in and help remove the oxygen consuming substances and get rid of pathogens and stuff like that. So they're not explicitly designed to remove emerging contaminants. And it's not the same type of, those things are not necessarily explicitly monitored in the same way and stuff like that. So that can be a place where you can see a lot of what's in the water. And a good example of that is that we've been doing some studies here in Iowa where we see really big spikes seasonally in antihistamines, which are allergy pills, right? In the summertime. It's like, well, I take those, hay fever, everybody, right? Kind of thing. It's a very normal type of thing. And you see that kind of getting present in the wastewater. And it's not something, some of it gets removed during the treatment, but treatment plants are not explicitly designed for that.
Thank you, Greg. Someone asked, are there any states that use emerging contaminant standards that exceed standards established by the EPA? And then a follow-up question to that, are there nations that use standards that exceed those of the EPA?
There are a handful of standards in different states. We mentioned PFAS, perchlorate in a few states. For emerging contaminants, California may have a few more. They have drinking water standards for, I want to say 3 or 4 dozen that exceed the EPA or are covering some different contaminants. So there are definitely a few states that have standards, but in general, that's not necessarily the case. And I think that's partially due to scientific capability and having the technical expertise within the state to evaluate the science and set the standards. And there needs to be some redundancy in that. And a lot of states don't have all of the expertise and all of the different emerging contaminants to necessarily pursue their own standards.
Is there any thoughts on like how we compare internationally for some of these contaminants? I know that's kind of a broader look that maybe it's past your knowledge, but just throwing it out there.
I think quiet. We don't know. I don't know off the top of my head.
That's all good. All good. Thank you. We have another audience member who asked about lead in Midwest water because they've read about it lately. Is that something that any of y'all can speak on? Greg, I see you kind of nodding your head a little bit.
I mean, lead is not people would not generally consider that an emerging contaminant. Because of the fact that it is regulated and we do know the health effects, there's no safe level, and we know how to basically solve it. It's a question of whether there are the resources and the will to do that. It is something that people are becoming more aware of, and that the problem is kind of becoming more to the fore because of the crisis in Flint, Michigan, and people can see how that affects people so greatly. So there are communities within Iowa, and we know that the University of Iowa has to get the lead out program, and working with communities to sample water and things like that. And so that's really important. I wouldn't consider it an emerging contaminant, but because when we've had these things, they've been known lead crisis.
Yeah, to add on to that, I mean, lead is, often we're finding it in like older lead pipes. And I know at least here in Wisconsin, a lot of cities have been removing their pipes, like here in Madison where I am, they're completely removed. Some of the other cities are moving in that direction as well. So it's a preventable issue. Oftentimes places like Flint where you run into issues, it's because they changed the water chemistry and the lead everything started corroding. And, so sort of when there's a change, but I don't know. I think eventually we'll get rid of them, but it costs money to do that. So I think that's probably the holdup there.
Mm-hmm. Yeah, I think that kind of goes along with another question that an audience member had. Assuming one has water coming into the house, it is as pure as it can be in 2023. Living in a 100-year-old plus house, what is the likelihood of contaminants entering the water from the time it enters the house until it comes out of the tap? So that sounds like it could be more of like, an old lead pipes issue, more so than like a emerging contaminant issue. But yeah, Chrissy, if you have anything else you want to say about it.
I was just going to say, I mean, it depends on if the lead pipes have been removed or not. My home is also 100 years old, but those pipes are gone, so it's not a concern. I mean, in general, yeah, the water that's leaving the treatment plants should be meeting the national standards and everything like that. So, but knowing what's in your distribution system and finding out like where you live, what exists there, I think is a really good thing to know. We're really generalizing. It's easy to generalize, but every place is different. So as much as possible, finding out where your water comes from, what test results are available, what infrastructure do you have, is really important.
Mm-hmm.
I think that was an important point, that outside of lead, there's very few contaminants, if any, or very few that where levels increase past the distribution point or the treatment plant. And so most water contaminant testing is done at the distribution plant, or the point of entry into the distribution system, I guess. And we also do maintain a national database of drinking water test results at ewg.org, where we've compiled all of the state results for different utilities. You can search by your zip code. And we actually pull up all of, I believe it's about the last 5 years worth of test results. Oftentimes there's more in there than you actually get in your consumer confidence report that has the testing that the utility is required to send you. And we also include information on what we know about the health effects of those different contaminants and where a health-based standard would be as opposed to just the legal limit.
Mm-hmm. And I know like we've talked about how, water coming out of your tap from a public water supplier is safe. Can we talk about like, there are instances where, for example, PFAS, like when levels were elevated in certain Iowa public water suppliers, they were required to send out public notices to the residents. Can we kind of talk about like the type of outreach that, suppliers are supposed to do if anything like that happens? If that's in your purview. No worries. Or David, if you have something.
Sure. I mean, most of the required notification is based on violations of drinking water standards, typically at the federal level, and then they're required to do outreach or send a letter to the customers or those who are connected to the water system. But otherwise, it's usually an annual consumer confidence report that shows testing results for regulated contaminants over the past year. And that is something that everyone should be aware of and should look at, and just to be aware of testing results and for their drinking water system. And this applies if you're on a public drinking water system. Obviously, if you're on a well, I think we would generally recommend consider testing and for the water quality in that well as a place that it doesn't fall under the drinking water standards of the EPA and the same testing requirements.
I think those consumer confidence reports are something that is a really valuable tool for the water consumers and end user, and you can learn a lot from them. And one kind of follow-up comment about from a well perspective is that from an Iowa specific context, and wells are not my area of expertise, but I do know that there are resources that are available to people that are on private wells for basically free testing services, so that and oftentimes people don't even know that those resources are available. It's funded by the states through the Grant to County program, and so you can get your well tested for all kinds of things. I'm not sure all what it covers, but that's, a good kind of rule of thumb that a lot of counties suggest is that, if you see high levels of nitrate in there, that's a good kind of a indication that you probably should do some follow-up testing, because that means that there's you're getting influence from things that are not just totally natural, clean water. And then you should probably do some follow-ups. And so those resources available, people should know about it because then you can use them.
Another audience question that we have is asking about the health effects of eating fish from Iowa's rivers and lakes. I'm going to throw this one to David first, because I know that the EWG had that whole study about PFAS in freshwater fish.
Yeah, so I just published a study, or was co-author on a study that came out just a month ago, give or take, where we looked at nationwide EPA sampling from a representative set of rivers and streams across the country, where they tested for PFAS contamination, and on average the values were incredibly high, and for anyone consuming those fish would likely be a significant, if not their major source of exposure for the year, even from a single sample of fish. And so that's a place where those results were about 8 years old on average for the freshwater fish testing, but indicative of how an emerging contaminant can also impact fish or species that people consume from a game perspective. And this was actually quite concerning, and why we highlighted in that study, just because of how the average level of PFAS in those fish would be representative of the same amount of contamination from a year of drinking water at the proposed MCL value. So it really stands out in terms of how much the levels in particular of PFOS accumulate in fish, and that's largely due to contamination of surface water. And so it's a place where more recent testing would be absolutely helpful. And there's an indication that those concentrations have been going down, but quite slowly. And it's still likely the case that in many, if not most locations, freshwater fish could have PFOS levels that are still incredibly high, and still would likely have a significant impact on your annual exposure to that chemical.
I think that's an important point, is we're exposed to chemicals in more than one way. Obviously, we're talking all about water in this session, but there are other places as well. Yeah, here in Wisconsin, we have a number of water bodies that have fish advisories for PFOS. And we're seeing, I feel like, more every month, it seems like, with more testing. So I'm not sure where Iowa is with testing, but I would imagine that could be an issue there as well, potentially.
I think I was just going to follow up that I think that the exposure to some of these chemicals that we know are highly impactful to the end user, from an exposure perspective, and from when wildlife like fish, or there are a few counties in Michigan where they have do not eat deer, and Michigan and Maine. And I mean, these are also environmental justice issues too, because like these are important sources of protein, and very traditional practices of fishing and hunting and stuff like that. And I think these are this is something that impacts the entire food web, and also the economies and the traditional practices of a lot of rural areas. So it's not just something that is a kind of a niche area too. Actually the USGS is doing have a solicitation out right now. They were collecting livers and spleens of white-tailed deer throughout the middle section of the country for a PFAS study that they are currently doing. So they were soliciting that. So I think that going and seeing how things move up the food chain is a really interesting thing too, because we're part of it.
Mm-hmm. Another audience question asked, are there any emerging contaminants that are found in rainwater? That is, are there such contaminants circulating through the atmosphere?
Yeah, there are. I mean, we're talking about PFAS a lot, but there is PFAS in precipitation, a few parts per trillion. So I guess probably well below the EPA proposed regulation, but there is PFAS in precipitation that's been measured across the world. So this is just another way of how these chemicals move around in our environment. I don't know of any other examples off the top of my head, though. I don't know if the other two do.
I would say in general, though, most of the time for a lot of these, I mean, example compounds that like the EPA lists and stuff, most of the time they're being picked up after the rain hits the ground in comparison to like if they're found in like stormwater runoff, and which is can be a that can wash a lot of things from surfaces that are in our everyday lives and then go into surface waters and transport those chemicals in. But in comparison to probably the rain itself more. So if you're collecting, I wouldn't put it as a high risk of collecting rainwater from a rain barrel and watering your garden with or something, if that was a motivating question too.
A question that I have is, we've talked about these different treatment technologies for that can help take out some of these emerging contaminants. Do we have any like technological limits thus far for any contaminants? For example, when I was talking with the Des Moines Water Works, they mentioned that toxins from harmful algae blooms are something that they've been struggling with. And right now they're just kind of avoiding taking surface water from areas with blooms, but they don't, have the infrastructure to do so. So I'm just wondering if there are any like limitations that we're still trying to overcome for, those kinds of technologies.
I can start. I mean, a couple thoughts. I mean, I already mentioned with PFAS, like we don't have a destructive technology. So we don't have that yet, at least not at a commercial or large scale. There's a ton of research going on this. And so we'll get there. But they're tricky. These chemicals are really hard to break down. For other chemicals, I don't know, it kind of comes back to, I think, David was talking about this earlier, the cost benefit analysis. Like there are advanced water treatment applications, like advanced oxidation processes and other things that you can break down all sorts of things, but there's a matter of like, do you have the infrastructure, the cost, balancing all those different things? It may just be better to avoid bringing in water when there's an algal bloom happening, rather than having like really advanced infrastructure. Yeah, so I think there are some, we're balancing things like what's technically feasible versus like what's practical. And so you kind of have to look at the whole picture.
I totally agree with everything that's there, and just add that you sometimes people will talk about like the push-pull of the energy requirements for these treatments is that you can go in and desalinate seawater, right? But it's extremely expensive and extremely energy intensive too. And kind of to follow up with the Des Moines, like they could remove they have the technical ability to remove the harmful algal bloom toxins. They're big nasty proteins and stuff like that. It could be done with their existing RO system. I'm probably not sized enough to treat their everything because they do blending of their nitrate removal and stuff. So it's possible, but it would be, that's a very expensive treatment process. It costs them a lot of money to kick down the nitrate levels in the Des Moines Water Works. And so changing it would make a lot more sense and stuff.
Well, we have entered our last 2 minutes. So I want to give each of the panelists time to, if you have a lasting message that you want to send to the audience, now is your time. So feel free to do so.
I just want to note that at least we talked about PFAS a lot, and it came up in a lot of the questions, is that we have seen levels come down. And on a slightly positive note with emerging contaminants, that as we learn more about the occurrence, as we learn more about health effects and action is taken to restrict their use or release into the environment, that concentrations have slowly come down in fish. They've actually slowly come down in people, at least PFOA and PFOS over the last decade. And there it's a big family of chemicals, and we still don't really understand the extent of contamination. But as those uses are restricted and reduced, that levels will likely come down in the environment, even if it takes decades. So there is a positive and hopeful side of this too, in terms of the extent that we know about the contamination of and the extent of emerging contaminants. And as restrictions are put into place where it seems prudent or health protective, that it will have a positive impact, and we will see a net improvement that likely will be for betterment of everyone's health.
I also wanted to try to put a positive spin on it, because this topic is a bit of a downer sometimes. And I think I have a lot of optimism just by how much energy there is in like the research community working on these issues, but more importantly, in the public and with our policymakers. Like, people are talking about water, they're talking about how to make sure water is safe to drink, talking about these new issues. And we're moving in the right direction. And so we do have, sort of as David said, a long road ahead of us. It's not going to be fixed overnight, but I know we're moving in the right direction. And so that gives me a lot of optimism.
I will echo both of those things insofar as that it's very, the most important thing that we can do to make sure that our drinking water is clean and safe and healthy is to keep our source waters clean and safe and healthy, and to keep the things from getting into there in the first place. And so it's not necessarily just about making the wastewater treatment plant better. It's about keeping those things out of our, the entire chain of things. And much of, for example, when we study neonicotinoid insecticides, much of that usage is actually not necessary and washes off, and it could be done in a much more targeted manner or something like that. So optimizing chemical usage, which is, these things can be really, really important tools, right? Nobody wants to live in a world where there isn't ibuprofen, right, for a back sprain, but we also want to make sure that we want to go in and use things appropriately, and that can, keeping our sources waters healthy will have important impacts for our ecosystems, not just our drinking water.
Well, we have reached the end of our time, so I want to start by thanking Greg, David, and Christy for being with us today. To the audience members, thank you so much for joining, and thank you for your great questions. And thank you again to Iowa Idea sponsor IPC Midwest and our in-depth week sponsor LaRue Law Firm for your support. As a reminder for audience members, we have our final expert panel tomorrow about how communities troubleshoot water challenges in their drinking water. So come join in on that. And final reminder that the registration for the full Iowa Ideas conference in October, which is free and virtual, is now open at iowaideas.com. So thank you all for joining, and I hope everyone has a great rest of their day.